Hi guys, welcome to my channel. In this video, we are going to be deriving the equations of uniformly accelerated motion. Okay, quickly, let's check what we have. In deriving the equations of motion, the following symbols are used. A represents acceleration, U represents initial velocity, V represents final velocity, S is distance, and T is time. So quickly, let's look at the first equation of motion. Now, acceleration A is given by change in velocity. Change in velocity over the time taken. So this can also be written as A equal to final velocity minus initial velocity all divided by the time. So acceleration will be equal to final velocity is v minus initial velocity is u over the time t. So let's cross multiply. We have a t is equal to v minus u. So let's quickly make v the subject of formula. So let's take this to the other part. So we're going to have u plus at is equal to v. So finally, v is equal to u plus at. So this is the first equation of motion. So let's look at the second equation of motion quickly. Second equation of motion, it is given by S equals to u plus v over 2 times t. So how do we derive that? Let's quickly derive that. Let's recall that average velocity is equal to u plus v over 2. Okay, and also average velocity is also known as speed, and speed, like we know, speed is equal to distance divided by time, which can be written as s over t. So average velocity is equal to this. It's also equal to distance over time. So we can say that u plus v over 2 is equal to s over t. So from here, let us make s the subject of formula. So what do we have? 2 times s, we have 2s equal to t times u plus v. We have u plus v multiplying t. So to get my s, we have to divide both sides by 2. So 2 will go out with 2. So therefore, we can say s is equal to u plus v all bracket t over 2. So this is the second equation of motion. Now let's quickly look at the third equation of motion. Now the third equation of motion is given by s equal to ut plus 1 over 2 at squared. Okay, how do we derive this now? Let's check it out. Now, from the first equation, we know that v is equal to u plus at. And we also know that average velocity is given by u plus v over 2. So quickly, let's substitute the value of v in the first equation into the v in this formula. So we have average velocity is equal to u plus v is u plus at, u plus at all divided by 2. So this can also be equal to u plus u, 2u plus at all divided by 2. So from here we can say average velocity is equal to 2u over 2 plus at over 2. So the 2 will go out with 2. We're left with u plus 1 over 2 at. So we're left with that. Now recall that speed is equal to distance over time. All right, so therefore we can say distance is equal to speed times time. And recall, our speed is also our average velocity, and average velocity has been given to be this. So therefore our distance s will be equal to speed, which is this, u plus 1 over 2 at times time t. Now let's simplify this. Let's open the brackets. So what do we have? Speed will be equal to t times u. We have u t plus 1 over 2 at times t. We have 1 over 2 at squared. So this formula gives us the third equation of motion, right? Quickly, let's look at the fourth equation of motion. The fourth equation is equal to v squared is equal to u squared plus 2as. All right, let's quickly derive that in a simple way. Now, from the first equation, we have that v is equal to u plus at. Let's make t the subject of the formula. So we have v minus u is equal to at. So having t, we'll divide both sides by a. So our t is equal to v minus u over a. Now let us substitute this formula into the second equation of motion, which is s is equal to u plus v multiplying t over 2. Let's substitute t. So this will be equal to, s will be equal to u plus v over 2 all multiplied by t is v minus u over a. Now let's simplify this. U times v, we have uv minus u times minus u, we have u square plus v times v, we have v square, plus and minus will give us minus, v times u is uv, all divided by 2a. Okay, now at this point, this will go out with this. So we have that distance is equal to minus u squared plus v squared all over 2a. So let's make v squared subject to formula. Let's multiply. Here we have 2as is equal to v squared minus u squared. So let's take this way. So we have therefore 2as plus u squared is equal to v squared. So finally we can say that v squared is equal to u squared plus 2as. So this is the fourth equation of motion. So guys, quickly let's look at motion under gravity. Okay, let's check that out. All right, we have motion under gravity, free fall. Okay, so the equation of motion can also be applied when an object is either going up or coming down. Okay, when an object is thrown to a height, our acceleration will be replaced by negative g, and at the maximum height, our final velocity equals 0. And when an object is released from a height, falling down, our initial velocity u equals 0, acceleration equal plus g. Okay, so therefore the equations of motion for an object thrown to a height or released from a height will be given as, recall the first equation is v equal to u plus at. Under gravity, this equation will be written as v is equal to u plus or minus g